Hey guys, welcome to your video notes on surface area of prisms and cylinders. So just a quick reminder, both prisms and cylinders have two congruent bases that are parallel to each other and are connected by a height at each vertex. Okay, so it's important to identify what those two bases are. To find the surface area, we have two options. Option one, add up the areas of each of the faces or the sides of the prism. So for a rectangular prism, if we imagine that this rectangular prism here, this I would label the length here, the width here, and the height here. To get the bottom face, or if we call this one the base, I would do length times width, but I have two of those. So I do length times width 2 times, or they in the formula here get this length times width times 2. Then to find the front, let's say, I would do length times height, and the back as well, so 2 times length times height. And then for the sides, I would do the height times the width on each side, so 2 times height times width. So that's where that's coming from on the sheet. It's still adding up the faces. So it depends on what type of prism, how many different faces you're adding up. It's important to make sure you don't miss the ones that are in the back or that might not be seen. So it's helpful to draw a net if you're going to do this. Now we do have a second option for finding the surface area. And this isn't on your sheet right now, but we can find the surface area of a prism by taking 2 times capital B stands for the area of the base plus P times H, where P or capital P is the perimeter of the base. Okay, so we're still essentially doing the same thing. We're adding the two bases, and then to get the area of all the other faces, we're using the perimeter and the height, because the height will be consistent for each one of those faces. And so this works for either a rectangular prism or a general prism, triangular, any type of prism. Okay, so the formula for right cylinder is really similar. 2 times the area of the base plus C for circumference times the height. So the same general concept, because when you take the circumference and unwrap it, it gives you that rectangular face that makes the sides, basically. Okay, so I'm going to show you how to do this on a couple examples using either method. So the first one, we have a cylinder, so let's use our formula. I always start by writing the formula down. Surface area equals 2B, capital B, plus C times H. Again, capital B means the area of the base, not just the side. So the area of the base here is going to be pi times the radius squared. My diameter is 14, so the radius would be 7 squared, plus the circumference, which is 2 pi r, so 2 times pi times 7, times the height of the whole cylinder, which is 12. Okay, so I'm going to evaluate these. If I leave it in terms of pi, I would get 98 pi and 168 pi, so combined I get 266 pi, so that would be the exact answer. But if I do it as a decimal, I would get 835.66 approximately, and this is the surface area, so it will be yards squared. Okay, let's look at number 2. Number 2, we have it looks like a trapezoidal prism here. So let's do this one by taking it apart. Okay, so let's take each of my bases. So I have 2 trapezoids, so let's draw that out here. And so for that face, I have base of 6 and 9, and I have a height of 7. So find the area of the trapezoid. I would do base 1 plus base 2, so 6 plus 9, divided by 2, and multiplied by 7. The final area is 52.5 of that face, but I have a congruent one on the back, so I'm going to go ahead and draw that out, 52.5. And now let's see, connecting, I have 4 different rectangles, so let's go ahead and draw those. So I have this one that is 6 by 4. Then on the sides, I do not know this length, so we need to find this length. So it looks like we might have to do some Pythagorean theorem here. Let's zoom in on this picture. They drew in this perpendicular line. So let's draw another one here. Assuming this is an isosceles trapezoid, we know the top length of the base is 6, so the bottom would be 6. If the whole thing is 9, that's 3 left over, so I get 1.5 on each side to give a total of 9. Okay, so I'm using Pythagorean theorem. I'm going to find this length by doing 7 squared plus 1.5 squared and square rooting. 7.16 for this side. So when I draw that out, 7.16 still by 4, and on this side it's going to be the same. 7.16 by 4. Now I'm just missing that bottom piece. That bottom piece has a length of 9 and a width of 4. So now I'm going to find the areas of each of these. This would be 24. 9 times 4 would be 36. And 7.16 times 4 gives me 28.64 and 28.64. Okay, so now my last job is to add up all these individual pieces. So all 1, 2, 3, 4, 5, 6 pieces give me a final surface area of 222.28, and this guy's going to be inches squared. Okay, last one that I'm going to do for you, number 3, we have a triangular prism. So this one I'm going to go back to the formula. I could draw out my 2 triangles, and then I would have 3 different rectangles here connecting them. I have this guy, I have the bottom, and then I have what looks like the side. So I'm going to use the formula instead, though. So again, my formula for surface area is 2 times the area of the base plus perimeter times height. Now, what's important here is identifying our base. Our base is the congruent shapes that are opposite each other. So in this case, the base is not what appears to me to be the bottom. The base is actually the 2 triangles. In a prism, you have to have 2 congruent bases. That's how you kind of identify. So there's my bases. So to find the area of that base, it's a triangle. So I'm going to use 1/2 base times height. So this lowercase b stands for the base side of the triangle, whereas capital B stands for the area of the triangle. So whenever I plug those in, that'd be 1/2 times 8 times 5, or let's see, 4 times 5. The area of the base is going to be 20 feet squared. The perimeter of the base P, I need to know my third side of the triangle. So I'm going to do 5 squared plus 8 squared and square root. And that gives me that this side here, we'll call y, is 9.4. And so to get the perimeter, 9.4 plus 5 plus 8 gives me a perimeter of 22.4. Okay, so now I know my perimeter, I know my area of my base, and we have our height is the distance between the bases. Height is not always up and down. The distance between the 2 bases, or in this case is 12. So now I'm ready to plug everything in. Surface area equals 2 times the area of the base, 20, plus the perimeter, 22.4, times the height of 12. So this one's going to give me a decimal. Let's see, 2 times 20 is 40. 12 times 22.4 gives me 268.8. Plus 40 gives me a final surface area of 308.8 feet squared. Okay, so make sure you write down any questions you have, but you're going to try 2 on your own. So what I want you to do now is pause this video, if it doesn't pause for you, and don't unpause until you've at least attempted the 2 problems, then we'll check. You can either use the formula or draw out the individual faces and find the total area. All right, let's see how you did. For the first one, my pen likes to erase things. I went ahead and drew out a net. I drew it all as individual rectangles and found that, it's rectangular prism. I have 6 faces, duplicates of 3 faces, and found the area of each face, total enough to get 214 meters squared. For the second one, I used the formula. So this is a triangular prism. I found the area of the triangle base. I like to shade that base so I know where my base is. From the area of that triangle and the perimeter of that triangle, needing to use Pythagorean theorem, and then plug that in. My height is the distance between the bases, which would be 10 here. Okay, so make sure you write down any questions you have, and then you're going to do problems 6 through 9 and check your answers on Drive so that you know if you need to ask your teacher any questions. All right, that's it. Have a good one, guys. See you later.